Welcome back everybody to the channel. My name is Nicholas and I will be going over this week's weekly overview. Today we will be discussing the topics from week 3. So without further ado, let's jump right into it. However, as always, I think it's best that we take a look at today's agenda. So this week we'll be talking about type hints as well as backpropagation. So what are type hints exactly? So type hints are a feature for Python that specifies the data types of variables, function parameters, as well as return values. So the main purpose of type hints is to improve the code readability as well as detect any early errors. So there are two ways to create a type hint. There is a way for when you want to create a type hint for a variable, and then there is a way to create a type hint for parameters and return values. Each have their own different syntaxes, which I will be going into detail here. So, how do you declare a type hint for a variable? Well, when you're trying to declare a type hint for a variable, you're going to want to use a colon followed by the type after the variable name. So, which you see here, the variable name is age, right? And we want to set that value. We want to set that variable to an integer, right? And then you can then set the value of the data type here to 30, right? Same thing with string. The name of the variable followed by the data type, and then the value of the data type, right? And the same thing with a Boolean: name, data type, value of the data type. Really straightforward here. Now, how do you use type hints for things like parameters and return values? Well, it follows the same structure as when you're using it for the variables. However, though, there's a little bit of an extra step here. So as you can see here, in this function, you have the name of the variable followed by the data type, but then it points. Then there's this arrow here that points to another data type here. So this is how and this works with not just strings but integers too, as well as arrays. So very versatile. So let's talk about why do you use type hints? What's the benefit of using a type hint? So there's numerous different benefits using type hints. One of them being it helps write shorter documentation. And writing shorter documentation is great for allowing developers of the code to help better understand the code structure and the intent of the code more easily. It also helps improve the editing experience by helping to catch many editing errors. For example, if you're trying to pass the wrong kind of data type, for instance, it'll catch that instantly. Another example is that it helps make coupling more explicit by defining the dependencies between the components in a code. So to really break down what that means is that when a function or class states that the type is associated with, it will then also reveal how closely coupled it is to other data structures and components. And then the final benefit that I found about type hints is that it forces explicitness about data structures by requiring the developers to specify the expected type of variables, return values, and even function arguments. So by doing this, it removes the sense of ambiguity. It ensures that the structure of the data is being passed around is clear, while also preventing any sort of runtime errors. So ArjanCodes made a great video discussing the top 5 reasons why you should use type hints. I'll put a link to his video in the description below if you're interested in getting a more in-depth version as to what type hints are. So next we're going to talk about backpropagation. So backpropagation is a algorithm which is used to train artificial neural networks by adjusting the weights to minimize errors. So this mainly happens by propagating the error from the output layer back through the network, which allows the model to learn and improve over time. Now, if you guys had watched my previous video, last week's weekly overview, you may start to think that this sounds a little bit familiar to gradient descent, which plays a key role into backpropagation, which I will touch on in a second here. But let's quickly break down what backpropagation is and go through all of the different steps of the algorithm. So, step number 1 is that input data is fed into the network. And when this happens, it passes through layers of neurons where the weights and the biases determine the output. The second step is that it compares the predicted output to the actual target. And we'll use a loss function to measure how far off the prediction is. Now, once again, if you watch my video from last week, you'll remember us talking about loss functions. Next step number 3, is that this is the real, I'll say quote-unquote, backpropagation part of the algorithm. So this is when the network calculates how much of each weight is contributed to the error, right? And it uses this by using the gradients, and these gradients will indicate the direction in which each weight should be adjusted to reduce the error. And then finally, you get to the last step, which utilizes gradient descent, and the algorithm will use an optimization algorithm like gradient descent, and the network updates each weight by a small amount. So the update is going to be proportional to the gradient, and will ensure that the error decreases over time by constantly updating. So that's all for this week, a very short week this week. I hope you guys enjoyed the content. Please do remember to like and subscribe, and I'll catch you again on the next week's weekly overview. Later.